for this program, after assuming the basic quantities for projectile motion like acceleration due to gravity, mass, initial velocity, time taken, number of time the loop would be running, which we'll see later on, maximum height, theta, which is angle at which the projectile motion was carried out, and dt, change in time. Let's assume the ball with the following physical properties, and we know that the maximum height can be calculated by using the formula u square into sine theta whole square divided by 2 into z, and we just calculated pi by 180 to change it to the radian. So now let's look at some of the calculations. Del v equals to vector 0 into z into dt into 0. Z into dt gives the change in velocity of the y component of the motion, and we know that since the x component does not change in the projectile motion, it's 0, and the z component is 0 too. Now we found that the x component of the component for the motion can be given by u into cos theta. It says the x velocity for the x component, and velocity for the y component can be given by formula u into sine theta, and the z component is 0. Now let's look at the loop of the program. While the above conditions are true, we are just keeping the count of how many times the loop should be running. That is, it's updating the value as each loop it's counting the number of loops. V equals to v plus del v. It is keeping in account the velocity of y component of the projectile motion that's changing. It's just updating the velocity of y component of projectile motion, and the ball position can be written as ball position plus velocity into change in time. What it is doing is that it's just updating the position of the ball. As we know that the position goes on changing, it's just updating the value. Now how we get the maximum height is that we first assume max height less than or equals to any height at which there is a ball, and we just take the value of max height to be the value of ball dot y if that max height is less than ball dot y. So what it does is that at one point it would take the max height would take the maximum value of ball dot y, and it will not update anymore. So in this way it will max h would get the maximum height at which the projectile motion is going. So now if ball dot y is less than 0, which means that the y component should be less than 0 so that the ball does not go below the ground. We are printing the position of the ball to be ball dot pose, time to be t plus n into dt. This is the fraction of time in which the motion is divided into total time plus initial time, and the maximum height to be maxh as we have already assumed, and this is the maximum height, exact maximum height that we have calculated using the formula, which is maxh inch. Now let's see and run the program and see what happens. As we see, the motion from initial to final with an angle of 45 degrees. We find the position of the ball to be 40.72 minus 0.05 and 0 meters, and time it has to be 2.88 seconds. Maximum height was 10.13, and maximum height that we calculated was 10.20. There's a little bit of difference in maximum height, and it is because as we see that the floor position is 10, -1 and 0, and we just kept this -1 so that it wouldn't look that the ball would come from